All right, welcome back to LagDemon Programming in the Compiler Design course. So we finally got a basic compiler working, and it spits out the abstract syntax tree in a manner that we can actually work with. Now, we're building a domain-specific language, or a DSL, and this DSL is very specific to our dungeon crawl game. So it's not going to have many of the things that you would find in a general purpose language because it doesn't need them. But it does need some basic things. And one of those basic things that it needs is the ability to print something to the screen. Now, we're going to do a very basic form of that for the moment. It's going to print to standard out when it executes. But later on, we're going to have to change that to be able to print to other syncs, other streams, because at some point in time we want to make this a multiplayer game and make it network based. So to do that, we'll have to refactor that a little bit. But I want to go through the basic process of setting up a print statement first. So let's go over to our. I probably should close some of these. I'm in trouble finding things. Yeah, I'm going to close this for the moment. So here's this one. So we do need, and I think we'll just use the word print. It's fairly common. Everybody knows what it means. And we will return a token that we'll call print underscore t for that keyword. So then we need to go back to our parser and we need to create that token up here. Oops, wrong place. We'll put it here. I noticed that I've got some things in here that I haven't used as well. I may clean that up at some point, but we won't bother with it at the moment. So a print statement is a statement. It's like one of the kinds of lines we can produce, and a line is always going to end with a semicolon, or a line can end with a semicolon, but it doesn't have to, depending on what it is. So let's go right here. We'll put it right here under function call, and we'll say it's print, oops, keyword. Well, yeah, it's going to be a print statement. And we will go that $$ equals $1. We'll have to create this object once we figure out what it's got. This stuff lined up more or less. And so we can do down here a print statement. And what's a print statement going to look like? Well, in its basic form, it could be print expression. Or it can be print string. I believe string is one of my concepts. Let's do this, put this semicolon place that needs to be there. What are our literals? String value. So it could be a string value. Let's make that a string value. Or it can print actually it can print any literal. So instead of this, we'll make it print. Darn it. We'll just print any literal. Or an expression. So it would that would allow us to print out variables and so forth. We probably also need some kind of a formatting thing. But I think I'm not going to mix it with our basic print. For now, we'll just be able to print out literal things and expressions, which also includes variables, which could potentially contain a string, because an expression can be a literal, and it contains all those. So we don't even need the literal. Actually, we're just going to print expression, because that can be any of those. It can be a string, it can be a boolean, whatever we want, or it can be a variable that we're outputting. So that's really it. It's print expression. So that means we need to go over here to our AST, and we have a here's our node. Oh, I did create an error node that gets injected in. I don't remember if I'm using it. No, I don't think I'm using it. In fact, I'm going to comment it out for the moment. Let's double check that, make sure. Oh, well, we got our print expression thing going on, so it doesn't know. Print statement, print. Let's go back to our parser. This needs to be print underscore t expression make, and it's still not gonna like something, because that print statement $1, yeah, we got to create that. Okay, our value, literal, identifier, parameter, function call, binary expression. We'll put it down here with, here's a let statement. We'll just go ahead and create a class called print statement. Public fng node. It's going to be an expression, so we'll have a protected expression pointer underscore expression, public print statement, expression pointer expression underscore, and that's it. And now we have to go back to our parser and say that $$ equals new print, no, print statement $2, because it's going to take an expression. And then up here, this print statement, that should work now. Oh, print statement has to have a type, and the type it's going to be is of type print statement, percent type. So that means we got to come up here. Let's find our let statement. There it is. Let's go print statement, pointer, print statement, and our type is going to be print statement, and it's going to be a print statement. Should work, hopefully. Nope, error has not been declared. Oh, yeah. So I think I want to get rid of this. And I think I want to go to, where's our visitor? Did I open it? Let's find it over here. Visitor.h. Do I have error in here somewhere? I don't see it. Error. Invalid expression. What's wrong with that? That's going to be an expression. $$ is a print statement. Oh, because print statement's abstract. Got to remember all these little details. Actually, we're going to need a getter for the expression. We need this except in here, and we actually need to put this, we need to do an except in here. We can get rid of this void except visitor pointer visitor. Oops, not that kind of visitor. Lowercase. And we're going to go visitor pointer visit this. Okay, our compiler works. So now we do need to go over to pretty print, and we've got to capture that print. So I'm going to go where let statement is. I think it's one of the first ones I did. Is it let statement? Yeah, we'll put it right after this. Visit, and it's going to be print statement pointer node override darn it. Having a little trouble typing tonight, so we need this here in the visit, in the visitor. I don't see it. Visitor, we need it here. So put it right after the let statement equals 0. And I think it's working. We can go to our test. I'm not seeing it. I'm blind. Test.fng, and we can come down. We'll come down here and do something like this. We'll go print. This is a test. Semicolon. Oh, I want to do that one, and it didn't like it. Oh, I didn't do it. Okay, I didn't print anything out for it, but it probably did it. There, yeah, see, it's empty. So we want to go standard cout print. And then we want to go node pointer get, okay. I said we needed a getter in here. Expression pointer get expr return underscore expr. And go back to our pretty print, and now we need to go node pointer get expression pointer accept this. Yes, compiler development can be very tedious, and there it is. Print. This is a test. We don't. You know, it's just printing out the actual value that's in there, rather than, you know, putting quotes around it and all that. That's because it's just printing the value it's stored. Let's go back to here and let's try some different kinds of expressions. Print 1 plus 2. Print quote a quote. Oh, that might not work. Print 7 divided by 5. Print 7 over 5. It doesn't like the A. print 1 plus 2, print 7 over 5. We could try print A. That should be an identifier. Print A, and accepted it. Still got to work out that problem with characters. I don't know why it isn't capturing the character correctly. Let's take a quick look at that. How much time we got? 15 minutes. See if we can fix that little problem while we're here. Parser.y, literal, character value, and $1 is going to be that char val, and it's going to be of type char. Okay. That all looks right. Let's go to our Lexer here. Double check this whole character thing here. A single quote starts it. Begin off. That's why. I'm starting a string, not a character. So char st. Putting the value in there. Returning char value. Make. Let's go to testfng and let's try out a character. Print quote z quote. Z. It didn't like it still. Double check this Lexer. Okay, a quote starts it. We begin character st. We clear the string buffer, which we don't really need to do. Append buffer, string buffer, YY text. We don't really need to do. We don't really need to do these. Oh, that's the problem. I'm doing YY text here. What we really need to do is make this str buff sub 0. That's where we need to get it from. Still didn't like that. A quote brings us out. Begin 0. Return character value. This is just going to generate errors, which it should. Huh. Okay, well, I will examine that offline, figure out what the problem is, and tell you about it when we come back to another video. We're about 18 minutes in. We have a working, more or less working print statement. This problem here has nothing to do with our actual print statement, but now we've got the ability to print at least something out to the screen, and we can make up variables that contain strings, and we can do formatting and stuff. We'll probably do one more command called format, and between the two, that will allow us to create a function, a library function that combines them together, being able to print out to the screen. We could actually even have some built-in things for different streams, like cout, cair, and so forth, and like that. So the other thing that we need to do is be able to get user input to be able to get something in, but we're going to save that for another video, and I got to think about that a little bit, how I want that to be formed up. So anyway, I think that's it for this video. If you liked it, hit that like button. If you really liked it, hit that subscribe button. And if you want to get notifications when I upload videos, hit that notify button. Thanks for watching, and have a great day.